Okay, we're looking at page 32 in the money management booklet. Bit of a misnomer. This unit doesn't really teach you how to manage your money, but it does hopefully make you aware of some of the pitfalls, some pitfalls to avoid with finance, and also how interest works, compound interest especially, right? So the big lesson from yesterday said compound interest is really good if you're investing money, right? If you have lots of money, it really helps that money grow a lot for you. But it's not so good if you owe money. So, because that takes a lot longer to pay things off, because they keep charging you interest on interest. And that's what compounding means. Compounding means that the interest that's charged then earns interest. Okay. So there was a formula that we're going to use. And it's the same formula whether you're investing money or borrowing money. And that was A equals P times 1 plus R over N to the exponent NT. And what do these letters mean? What does A mean? Yeah, final amount. And P was what? Nope. Yeah, that word is principal. And what is principal? Yeah, it's your starting amount times 1 plus R, and R is your interest rate. And make sure you turn that into a decimal, as a decimal. Okay. And what else? N is simply the number of times they calculate the interest. How many times the interest gets calculated on what's already happened. So number of compounding periods per year. Just think of a compounding period as that's when the bank figures out how much interest is earned or charged. Number of compounding periods per year. And T is just time in years. And then it's just a matter of practicing to use the formula. It's not too bad. Okay, so complete the following table. I know what my P is, I know what my R is. Okay, let's turn that into a decimal first of all. 1.25% is what is a decimal? 0.0125? Good. I might as well do all these, right? It's a chart, I can fill it out faster. I'll do them all. 0.0435, 0.0315, 0.0399, 0.0515. Oh, this one's confusing. 0.75, you have to know how far to move it. If I'm not sure, what's a guaranteed way I can convert that correctly? Yeah, divided by what? 100, yeah. I'm just going to go 0.75, and I'm going to divide that by 100. Oh, and there we go. I'm going to get 0.0075. That's the number I got to use. I apologize if I start sneezing a lot. I'm allergic to spring, so I pretty much know when the weather hits 0 because I start sneezing a bunch. All the mold spores and whatever wake up. Called hay fever. Anybody get sick this time of year? Every year?
Summer.
Yeah. Yeah. Usually means you have allergies. Yeah. Most people they think, oh, I seem to get a cold every year in spring. No, it's hay fever. Okay. Compounding period. So that N equals, if it's annually, N equals 1. If it's semi-annually, N equals what?
So
2. 2 times a year they're going to calculate it, like mortgages. Daily, how many days in a year?
365.
Yeah, we use 365. Quarterly?
4.
4. Weekly? How many weeks in a year?
26.
So yeah, 26 would be
52.
bi-weekly, yeah. So there's 52 weeks in a year. And annually n equals 1. Okay, now these are all in years, so those are good. Those are my t's, there's my n, there's my r, there's my p. It looks like I know which numbers I need to use now. So total value of investment. Okay, A equals P, which is 400, 1 plus 0.0125 over 1 to the exponent 1 times 5. Remember, whatever number you put down on the bottom here of that fraction goes up on the right. So 1 times 5. And if I punch that into my calculator, now some calculators will let you punch in 400 bracket, and it will know, your calculator might know that means multiply, but I don't know your calculator. I don't even know if this one does it. So I know that when a number is beside a bracket, it means to multiply, so I'm actually going to hit multiply. So 400 times bracket 1 plus 0.0125 divided by 1, close the bracket, to the exponent. To me, that's the YX key. And I always use a second set of brackets, okay? That way I won't make a mistake. It doesn't have a second set of brackets in the actual formula, which you can't see. There you go. Okay, it doesn't have a second set of brackets, but I always put them in because that way it won't make a mistake. Because otherwise, if I don't put it in, it might think that I'm only using one of those numbers in the exponent when it should be a product. Okay, so it's just to be safe. So to the exponent, 1 times 5. And I get an answer of $425.63. So it was $400 to start with. It grew to $425.63. So how much interest was earned? Yeah, $25.63. Which, if formally, I could say if I just take A minus P, the final amount, subtract the starting amount, I'll get $425.63 minus 400. Which is $25.63. Okay, it's not a lot of money because the investment was very small, $400. Okay, next one. I'm going to go 2,500. 1 plus 0.0435 over 2 to the exponent 2 times 2, it looks like. And I get an answer of $2,724.70. Anybody else get that? Yeah. And if I subtract the starting 2,500, I get $224.70. Somebody else got that? If at least one of you got that, I'm going to assume that 2 of us are correct. Okay. Okay, next one. $33.60 times 1 plus 0.0315 over 365 to the exponent 365 times 6. And just be really careful with your calculator work. It's so easy to accidentally hit a wrong operation or number. I'm rather paranoid when I do things like tests, so I always do things twice. If the 3-hour exam and I'm done in 2, I spend another hour redoing every question. But it pays off. I did have a calculus course in university where the calculus professor who had been teaching there for decades found me after the course and said I wrote the highest exam that she'd ever seen in her around 20 years of teaching there. Said I'd lost like half a mark or something, 99.5% in a calculus exam. And by doing exactly that, redoing every question, I felt like there's no way I got anything wrong. But apparently I didn't make a mistake somewhere, and it still bugs me. But I got an A+, which is the highest you can get. So this works out to $4,058.98. Anybody else get that? Yes? If not, we'll redo it.
97.
You got 97? Okay, let me do it again. Let me check my numbers. 3360 times 1 plus 0.0315 divided by 365 to the exponent 365 times 6. 4058.98. This 0.98. Okay, awesome. It's actually a significant amount of interest earned if it's an investment. $698.98. The next one is 5,001 plus 0.0399 over 4 to the exponent of 4 times 4. Is anybody willing to admit they like doing these things repetitively, like over and over again? Yeah. Every time you get the answer right, does it make you feel good? Just a little bit? Yes? A little bit? That's dopamine. It's dope. Right? It's like playing Candy Crush, and I don't know, I've never played it, but I imagine it must bling or do something to make you happy every time you do something right. It's like video games, right? Just do every time you get a little hit saying, hey, you did something right, I feel good about that. Right? So 1 plus 0.0399 divided by 4. Okay, $5,860.57. Yes? Okay. And then when you subtract the original amount, you'll get $806.57. Next one's 15,000 times 1 plus 0.0515 over 52 to the exponent 52 times 10. I love these repetitive things, just doing it over and over and over again, because then it makes it like really automatic and be easier for you on a test because you've done it a bunch of times. That's how we take things we've learned and we put them into what's called long-term memory. When you repeat something over and over again, it moves into long-term memory, which means you'll always kind of remember how to do it. If it's in short-term memory, like if you learn something once, you use it, it's a lot harder to recall it. Okay, so 15,000 times 1 plus 0.0515 over 52 to the exponent 52 times 10. So that's $25,098.18. Anybody else get that? Yeah. And if you subtract off the 15,000, you get $10,098.18. It's okay, like, there's really no rule about notation. It's okay to put a comma there if you want. Like, doesn't matter. Some calculators actually put commas. This one here, you'll notice it puts like a little, almost like a comma, but it puts it up at the top, which is weird. But just to help you read the number a little bit easier. And the last one. 100 times 1 plus 0.0075 over 1 to the exponent 1 times 1. Okay, this is a small amount of money, $100, and it's being invested for 1 year at a really, really tiny interest rate. So I would expect that my answer is going to barely move above what, $100. Okay, the interest rate's so low, you're not going to earn much on it. So let's just see what happens. 100 times 1 plus 0.0075 over 1 to the exponent of 1 times 1. And I get $100.75. It's earned a whopping 75 cents in interest, sitting in there for a year. So how much interest was earned? Well, 75 cents. Not a heck of a lot. Anybody else get 75 for that one? Yeah. And I guess the lesson learned there is if you only have $100 to invest, maybe don't bother. It's not going to earn a whole bunch. Okay. Number 2. So these are word problems. Mohammed invests $6,500 in a financial institution at 5.25%. I'm already above that. I'm going to write down this because I know that's what I'm going to use. Compounded bi-weekly, so that's every 2 weeks. So that's going to happen 26 times a year. Calculate the total value of his investment at the end of 10 years. That's my T. This is my P. Okay, I can do that. A equals P1 plus R over N to the NT. A equals $6,500. 1 plus 0.0525 over 26 to the exponent of 26 times 10. And then it's just calculator work. Generally on a test, every one of these questions is worth like 2 marks. And make sure you don't just punch everything into your calculator and write a number down. Because if we're marking it, and same thing when you're doing provincial exam in the grade 12, if you put a number down and it's wrong, they have to give you 0 because they don't know what you've done. So make sure you actually write out like this, the numbers, because if you do that, you could get the wrong answer, and you could still get like 1.5 out of 2. Like if you wrote this down correctly and got the wrong answer, they'll just say, oh, it's a punching error. That's only a half-mark deduction. It means you knew what you're doing. Okay? So make sure you write it out. I know some people just like to punch things in and do it, but you want to maximize your potential for getting marks when you do make errors. And we all make errors, right? Except for me. When I make them, it's deliberate just to make sure you're paying attention. Okay, 6,500 times 1 plus 0.0525. over 26, close the bracket, to the exponent of 26 times 10. And the total value is $10,982.17. Anybody else get that? I realize some of you may not have got there yet. But when you do it on your own, that's what you should get. We'll see what the answer key says too. If I can find the answer key. Yeah, there it is. At the back, 10,982.17. Good. Number 3, Bill bought a $1,500 GIC. What's a GIC again? Ah, it's a certificate. You're right. Yeah, that's the guaranteed income certificate. So it's like they guarantee you that you can't lose your investment, that you'll get a return on it. They're like it's considered a really safe investment. There's no risk involved. It's government backed. You'll get the money, but usually because it's so safe, the interest rate's really low. Usually they don't offer that much on them. Okay. The certificate matures in 5 years. That means it matures in 5 years means you can't get the money for it for 5 years. It's locked in. Okay? So it's not flexible. Once you buy it, it sits there and no one can touch it until the time's up. It earns interest at 3.5%, so it's low. It's pretty accurate to what you would get. Compounded once a year. How much interest will Bill receive when the certificate matures? Okay, so this is my principal. That's my time. There's my interest rate. Compounded annually, n equals 1. That's all I need. So A equals 1,500. 1 plus 0.035 over 1 to the exponent of 1 times 5. $1,781.53. So that's what it's worth, but the question was how much interest. So how do I figure that out? A minus B, yeah. So 1781.53 minus the starting amount of 1,500. The slick thing to do is not clear your calculator. You just leave it in there and go minus 1,500. And that's $281.53 interest earned. It's not significant on a $1,500 investment, but it's better than nothing. And more importantly, it's a good forced savings, right? Any kind of investment where you don't have the option to pull the money out is pretty good. It's like guaranteed you can't touch it, right? Okay, number 4. When Xavier was born, his grandfather deposited $5,000 in a bank account for his college education. Well, isn't that nice? The account earns 6.5%. Ooh, it's pretty good too. That's not bad. Compounded monthly. How much will the investment be worth in 18 years? More importantly, at 18 years old, is Xavier going to use the money for something good? Probably not. It's 50. And but I was allowed to eat there, and the only thing they sold was pizza pops. So I ate my weight in pizza pops on Saturdays and Sundays. I felt just as good as you'd expect me to feel eating nothing but pizza pops. And then I would literally eat nothing but like rice all week. was not a great diet. And that can all be attributed to the fact that I wasted the money I had. So live and learn, right? Hopefully none of you have done stupid things with money like that. Okay, so let's see here. So it was 5,000 at the start. The interest rate wasn't too bad, 0.065. It was compounded monthly, so that's 12 down here. And then it's going to be 12 times. Now here's the real important thing, investments, time. 18 years is enough time to hopefully significantly increase. And that's the whole idea with, remember I told you about RRSPs? Once you have the job, you're going to kind of, work full time. That's your job that you hope to keep for a long time. That's a good time to start buying RSPs, even if it's like a small amount, like $50 a check or something. And just have them take it off so you don't see it. It's a lot harder if you get the money to go and buy something. It's a lot easier if the money just disappears, right? And then next thing you know, like many years later, like you get this little statement saying, wow, there's like thousands of dollars in here. And then 20 years later or 30 years later, it's significant, right? So that time is important. So let's see what happens here. 5,000 times 1 plus 0.065 over 12 to the exponent. 12 times 18. So that $5,000 sat in there doing nothing but growing, and it grew to $16,059.18, which is enough money to pay for a few years tuition at university or most college programs, so it's not bad. Of course, Xavier being 18 and having access to the money might blow it on a stupid car and get caught in the trap. In high school, you used to be able to get your license at 16, your full license, and you used to be able to buy a car for $100. $100. And it wasn't worth more than that. Like the city was littered with horrible cars. But as a 16-year-old, any car was great, right? And I lived in East Transcona, so if you didn't have a car, you didn't actually get to visit like the world because you were like at the edge of nothing. And a lot of us fell into the trap. I was one where I got a car and then I got a job, but my job just paid for my car. So I spent all my time working to pay for the car, whereas I would have been better off. Again, you have to learn those lessons. I would have been better off to like just not work. The car expenses and stuff like that. Okay. 60,059.18. 5. How much interest is earned on a $2,000 investment? I'm going to speed up here and just start doing it. $2,000. 1 plus 0.055. It's semi-annually, so that's twice a year. So I'll put a 2 down there. And it's 5 years, so I'll put a 2 times 5 up there. So find the final amount first. One plus 0.055 over 2 to the exponent 2 times 5. It's $2,623.30. So if I do A minus P, I'll get my interest earned. So 2,623.30 minus the $2,000 at the start is $623.30 interest earned. And maybe I should just double check the answers there, and they look good. So At first, when you looked at it, the formula kind of looks intimidating. You got a bunch of those letters in there, right? A, P, N, R, T. But once you've done it enough times, hopefully you'll be okay. Okay, you'll be okay. Do you want me to do the rest, or do you want time to finish them on your own? I know you love putting your hands up. How many of you want me to do the rest? 3, 4. How many of you don't want me to do the rest? Okay, it's a high. Your voting is almost as good as like federal elections, you know, or municipal elections. Like nobody goes to vote. It's the strange thing about democracy, you know. Democratic countries, nobody wants to vote. They have the right to vote, but they don't really exercise it. Okay. Fine, I'll finish them. A whopping 4 votes. Okay, number 6 on page 34. Wanda has $7,000 to invest for 3 years. It's one of these long questions. If this is a test question, it's probably going to be like 4 or 5 marks because there's a bunch of parts to it.
It is.
But it's one of these ones where you're doing 2 questions. You're doing it once using these numbers, then you're doing it again using these numbers, and then there's usually a question at the end that says, what's the better deal? That's the way they all work. Okay? I think yesterday we did one comparing a simple interest versus a compound interest. Which one's better? But they all work the same way. You're just doing 2 questions, and then you're saying which one's better. Okay?
Oh, yeah.
So that's where you get the 2 marks for doing the 1 A equals P, 1 plus R over N T thing. And then you get 2 marks for the other one, and then an extra mark for answering the question. So don't be intimidated by like all the size of it. Okay, the size of it. Okay, so there's Bank A. How much is it worth choosing Bank A? Okay, so Bank A is going to be $7,000. 1 plus 0.0725. And it's compounded semi-annually, so that's a 2. And it's 2 times 3 for 3 years. We'll just punch that in. And we get $8,667.33. Okay, and let's do Bank B. The interest rate changes to 0.0635, and the N changes to 12. $7,000, 1 plus 0.062. Oops, I messed it up. 35 over 12 to the exponent 12 times 3. You get $8,464.73. Okay, so which one earned more? Yeah, A is worth more. So it says, C, which bank gives her a better return on her investment? So Bank A is better. And then it says, by how much more? So if I want to figure out how much more, I can just subtract the 2, right? Bank A is better by, I'm going to take 8,667.33 minus the smaller amount, 8,464.73, and I'll punch those in. $202.60 better or more. Okay, so you earn an extra $202.60 if you go with bank A versus bank B. Okay. So this formula is actually useful to you if you're ever taking out a loan. So quite often people only look at the interest rate. If they see that this one's 3.5 and this one's 3.25, they might just assume if it's a loan, they want the lower one. They'll say, oh, the 3.25 is better. But you should probably find out about the compounding periods, right? How often is the interest calculated, and do the calculation, right? So it is a mathematical tool for you to help you make a better decision. If you're borrowing money, you want to make sure that you find out which is the lowest interest rate, right? You pay the lowest amount. If you're investing money, you want the one that, of course, makes you the most. Of course, you could always just say, what's the effective rate? I don't care what your posted rate is. What's the effective rate? That means, you know, it's posted at 3.25, but what is it really once you put all the compounding in there, right? That's more important. And you can figure it out yourself using this formula, right? So let's say, this isn't in here, but this is just if you were shopping around. Okay, so let's say that you have, a lot of credit cards work this way. Let's say your credit card has an interest rate of 19.99%, okay? Now, we know that credit cards are probably going to charge the interest more often than just once a year. So even though it says your credit card's 19.99%, it's probably going to charge you more than that because of the compounding periods. So if you just started with with 1 as your principal and went, okay, 1 times bracket 1 plus 0.199, the 19.99%, and you divided that by, it depends on the terms in your credit card, the really tiny print that they don't expect you to read, but you're going to read. Let's say it's compounded daily. That's 365. Okay. Then to the exponent, it would be 365, and we'll just do it for 1 year, times 1. Look what happens. It gives me 1.2212. If I subtract off the dollar that I started with, what's the real interest rate it's charging me? If I times it by 100, 22.12%. So it's posted as 19.99, but its effective annual rate is actually 22.12 because of that compounding periods with 365. Okay. So in the, I think by law, they actually have to give you this number in the small print. So they might have the big number on the envelope when they say sign up for this card, but the real number has to be somewhere in the small print. That's why you always read the small print. So you look for the terms effective annual rate. That's the one that really matters, not the posted rate. Just so you know. Okay? So if you're eventually getting a credit card, you're responsible enough to handle a credit card, and you're comparing, that's what you want to compare. Not the number on the envelope, but what's in the small print. Or you can do the math. Okay, which one do you think I prefer, doing the math or reading the fine print? Yeah, it's true. It's right there. It's printed in there. But if I can't find it, then I'll do the math. Okay, number 7. Which gives more interest when compounded? Annually, semi-annually, or quarterly? So this is n equals 1. That's n equals 2, and that's n equals 4. So which one generates more interest? 4. Yeah. The more compounding periods, the more interest. Okay? For good or bad. If it's a loan, it's bad. If it's an investment, it's good. Okay? So the highest value for n gives the most interest. So in this question, quarterly. 8, why do financial advisors say that simple interest is better if you're borrowing money, but compound interest is better when you're investing money?
Interest.
Yeah, it has to do with interest on interest, right? Yeah, when you're borrowing money, you don't want to pay interest on interest.
Yeah.
But when you're investing, you absolutely want the interest to earn interest. So it's kind of the whole idea that we've been talking about. So compounding when borrowing, bad. Compounding when investing, good. That's basically it. So however you want to say that. Compounding hurts when borrowing.
Basically, you get screwed.
Yeah. Yeah. I mean, if you're borrowing, you're already getting screwed, right? But you get screwed extra if there's a lot of compounding happening because it's charging more on what you already owe. So it hurts when borrowing. But what's the opposite of hurt? Which one?
It has more benefits.
Yeah, but benefits, yeah, sure. Yeah. But benefits you when investing. Okay. It's a stage of life thing too, right? You're in school, you're probably more of a borrower than an investor, right? But eventually you'll be in a position where you could be an investor. Right? Okay. That is kind of the unit. Tomorrow, so you should try to finish it up if you're missing some stuff. Tomorrow I'll give you a practice test that will look the same as the test, right? And I'll give you some time to do that. We'll correct it together so you'll have an idea of what you would get if you had taken it as a test. And hopefully you'll be able to figure out the mistakes that you made and do better on the actual test. Good? All right. You can hang around and do a bit of work, or if you want to take off, it's okay. Oh wait, I shouldn't have said that while I'm recording. You're required to be here. Oh, I thought class was over, but it isn't officially over. So yeah, you've got some time to work.